Hi and welcome to Cherry Pie Math. This video is going to introduce solving for exponent bases and exponents. It is not going to cover if it has any coefficients or anything added onto it later. It's just going to be your basic monomial exponentials for solving. So before we get started, you should know what an exponent is and know what the inverse for the exponent is. We are going to review it a little bit, but if you want to go more in depth, there's a link to the video here. Okay, so just to get ourselves thinking, what do you think the base for x squared equals 9 would be? So if you guessed 3, you'd be right. 3 makes sense because 3 times 3 equals 9, and we're looking for a base that multiplied by itself 2 times, since the exponent is 2, would be equal to 9. So with that in mind, let's write down exactly what it means to solve for x, because you'll hear that a lot, like solve for this. Solving means to find out what x is equal to make the equation true. So we always write our answer as x equals the number, or whatever the variable is, like if it's x or a or y or whatever. I know that I'm super picky about this, and it kind of depends on your teacher, but if you write a number like 3 in the middle of the paper, it doesn't technically mean anything because 3 is a number. But if you write x equals 3, then I know that you know that if we plug in 3 for x, it makes the equation true. So that's what it means to solve for x. It means to find the number that you can plug in for x, or the variable. So to solve for x as a base, we need to perform the inverse, because an inverse will get rid of the exponent. Kind of like if I did x plus 5 equals 13, then I'd have to subtract 5 from both sides to get x by itself. And so to get x by itself, we have to apply the inverse. So the inverse of an exponent is the radical of that same exponent. So if the exponent is 2, then the inverse is a square root. If the exponent is 3, it's a cubed root. If the exponent is 4, then it's a fourth root, and so on. A radical is just a root, meaning like a square root or a cube root or whatever. So to get rid of an exponent, we apply the appropriate root. Okay, so let's do some examples so that makes more sense. In the first one, we have x squared equals 16. Since the exponent is 2, we would need to square root both sides. Since the golden rule of mathematics is you do to one side, you do to the other. So that gets rid of the square. If I square root both sides, it gets rid of the square because they're inverses. So now we have x equals 4 or negative 4. We actually have 2 answers here because either one squared would give us positive 16 when we square it. I don't know how picky your teacher will be. It kind of depends on how old you are. If you're in middle school, honestly, I don't think I would care all that much. I would probably just think 4 is fine. Maybe I should care more. But if you're a junior or older, I'd be like, nope, that doesn't count. And I'd only give you half credit on that answer. You'd have to show anything that you can square to get to 16 in this case. So in this case, it would be 4 and negative 4 because both of them squared, both of them multiplied by itself would give us positive 16. Same idea applies to the next one. So if we square root both sides, you get y equals 9 or negative 9. If you're super good at knowing your squares, you could probably be like, oh yeah, I just know that 9 squared is 81, so the answer is 9. You wouldn't even have to square root both sides. You could also guess and check, or just try a bunch of numbers to see what makes 81, and that's fine too. A lot of these are just to make sure that you know that, like, the properties of exponents, so that the base is what you multiply the amount of times of the exponent. The next one, x cubed equals 8, is the same but with a cube root instead. So you'd cube root both sides, and then you'd get x equals 2. It would not have negative 2. Negative 2 times negative 2 times negative 2 3 times would still be negative 8, since there would be an extra negative that doesn't cancel out. Since the next one is negative, that means my base should be negative as well, since it's a cube. So my answer would be negative 3 after you cube root both sides. So what about x squared equals 2? Well, you'd square root both sides, but the square root of 2 is irrational. It doesn't actually come out to a nice number because 2 isn't a perfect square. So we'd actually just leave it as a square root of 2. And we usually don't convert it to a decimal because then it's not an exact amount anymore, since you'd be rounding it. If you have a number that isn't a perfect square, you'd simplify it as much as you could using a factor tree kind of method. But if it is a perfect square, get that number out. So like 9, the square root of 9 is 3. The square root of 16 is 4. But if you have like the square root of 20, then you'd have to do your factor tree and you'd have to simplify it and leave it in that form. You would not change it to a decimal. We can do the same idea with finding exponents. And honestly, this might be even easier since it really is just a lot of plugging it into a calculator until it equals what you want. So like in the first one, 3 to the x is 81. So you would just keep multiplying 3 by itself until you get 81. 3 times 3 is 9. Multiply that by 3 again is 27. Multiply that by 3 again is 81. And that was 4 times. So my exponent is 4, and I'd write x equals 4. Remember to use x equals. The next one is a fraction, which might throw you off, but all it does is make your exponent negative, right? So 2 to the 5th is 32, and since it's a fraction, my answer would be a equals negative 5. The next one is a little weirder still. Since both sides are negative, I can actually just ignore it. It's kind of like dividing out a negative 1. So I just get x equals 2. Tens are fun because you can count the number of zeros, and that tells you what the exponent is. Since this one has 3 zeros, it would be b equals 3. Anyway, some things to remember. To solve for a base, take the exponent's root, like square rooting for squares or cube rooting for cubes. And then if you want to solve for an exponent, find out how many times you multiply the base. Mostly it's just guess and check, TBH. Okay, anyway, I hope that helps, and good luck.